What's up, folks? So I wanted to make a video about Stardeus Unity project and how it's structured and how Stardeus is using Unity in what ways and how it works. So I hope this will be interesting for some. Now, most of the time I work in this view here, where this layout where we have the game. We do have the test runner with tests. And there's console, and there's hot reload, and my tool for switching some things in the game and just showing the memory consumption and all that. So yeah, as you can see, there's no scene, there's no hierarchy, because I mostly not use that directly. I rarely have to work with it, because most of the stuff is done in C# through code. So we'll get to that. Now, where do I begin? Okay, so when you have a new Unity project, what's the first thing that comes to mind? You have to open a scene, right? So let's take a look at the scenes. I'm going to switch to full edit view, which will have a bit more familiar layout, I hope. And here we will have scenes folder somewhere. There, scenes. So there's, what is that? It's not supposed to be here. Anyways, I think I can delete this. Some mistake, I think. Yeah, so we have the main menu, game and empty. Empty scene is something that is loaded when we switch between game and menu. So it's basically like a cleanup scene. And when we start the game for the first time, we get into the main menu. Then from the main menu, we hop into the game through the empty scene. And then from the game through the empty scene, we can hop back to main menu. So let's open the main menu first. And here you can see that it's a little bit empty. So if we expand everything, there's just a couple of things here. But if you launch the game, see what happens here. We launch the game. And suddenly hierarchy changes. So you have all of it. Let's wait for it to load. And we have things happening. So suddenly there's a lot of objects. And how do they spawn in here, right? How do we have them? And why are they not in the scene when the game is not running? So the first thing we should look at is this UI menu root loader. So this actually hides a little bit of stuff in here. So it's a very simple script. Let me open it up. It's a very simple script which just takes a prefab, and then when the Unity awakes, it loads this prefab and destroys itself. So it loads this UI menu root prefab. So basically everything with the UI, especially everything is in prefabs. And one reason for this is because when we save a scene in Unity, if you have UI with GUI and like vertical layout groups and stuff, you know probably that Unity always touches them and the scene is marked as changed every time you open the scene. So to avoid that, I have invented, quote unquote, this load prefab thing, and I'm loading this prefab, which now you can see here, there is much more to it in the scene. So the prefab of the main UI container and all that there is in the main menu is decoupled from the scene. It's not the same object, not directly in the scene. Okay, so this is the main menu, but it still doesn't have buttons. The buttons are spawned through scripts. It doesn't have the panels. Panels are spawned through scripts. So it's just like a placeholder. Okay, so now let's see. Maybe I should say how all this works in code. Like what happens when you run this main menu thing and... Well, you know, let's just run the game. So when the game is booting, it's loading resources. Actually, I could talk about this a little bit as well. So how do we load everything? How do we load everything? If you open, there's this core mod here. So I'm trying to make this game moddable, which means I'm trying to expose almost everything to the player in plain formats. There's like Unity, normally if you have Unity project, all the images, all the sprites that you use, everything will be packaged inside binary files like Unity level files or asset bundles or whatever, but these files are not open to the players. What I did here is I have like this mod here, the core mod, and the game loads this mod. So for example, if we go to graphics folder and we go to say something like beings, bodies, I don't know, dog, and you'll see that there's like 2 types of dog bodies with all the sprites. These sprites are coming from Blender. I have 3D models and I have automation with scripts that exports them in all the right rotations, and then we can use those in game. So now how do we load these files when we load the game? So Unity has to find them, and for this reason this mod is actually sitting in the streaming assets folder, and it's a special folder in Unity. So Unity doesn't do anything to files in that folder. It doesn't package it into levels or asset bundles. It just keeps them as they are. And then I have this thing called mod loader, which loads, let's say, trial and graphics. Okay, so it tries to load them cached. We have the graphics cache as well. So if we fail to load the graphics, we load the textures and we create that cache. So how does that work? There's this, in the end we get this texture 2D, and we're loading like path to the files. So we read the files, read the directory, load the textures, and then we have them that we can use. And of course, we just don't load each texture separately. We package them in atlases. So you can see how that looks if we go into, say, the cache directory here. So you can see that we are packaging these files, like this is the dog. See, these sprites here were dynamically packaged into this big atlas at runtime. So when the game launched, all these files were created, and this is more efficient for GPU because the GPU loads these big atlases, and then it's easier for it to, say, reuse the texture when displaying multiple items. It's more efficient that way. Okay, what else? So we figured out how do we spawn. How do we fill the UI? And okay, let's maybe get back to main menu again. I'm not done with it yet. So in main menu, we have the UI, right? What else we have here? There's a couple of cameras. So there's the root camera. If we turn it off, you can see that the view just freezes because there's nothing happening. But this root camera consists of UI camera and dust camera. So if we disable, let's find the UI camera first. There's this UI camera here. If we disable it, it's dark. So this is filming the UI. And the dust camera is for the visual effect that produces this little dust above this. But is it not visible anymore? It feels like there's no dust. Huh. Yeah, I think I removed the dust, but the camera still remains. So this is something I could probably remove right now. Well, dust camera is used in game anyway. So when we start the game, there's dust particles and we're filming them with a separate camera. But it doesn't matter right now. So what I want to cover here, there's this menu, right? So it's built from prefabs. Each button here is... let me find the prefab. Main menu... button. So if we open this in the scene view, we'll see that there's like simple button with text, which looks nothing like that one. So that's another thing I can talk about. There's the styling applied to each button. And if we look at this in the inspector, we can see that there's this UI style button script. We can open that up. And here it says that this config ID is button/main menu. So this config ID, if we find button/main menu, you'll find that this is like a JSON file which has some configuration here, and all the UIs, all the looks of the UI are defined through these UI JSON files. So let's say we go to panel and say something like this or that, like data block header panel. You can see that it's using the image UI buttons button top BG. It's sliced. This is the slicing, and it uses the color of UI panel header. Then you can just find the colors with this ID and so on. So all this is exposed to the player. If I go again back to core mod, all this is the config, UI, button, all these JSON files are here. So yeah, so that's how the styling works. Also the images for these things. So if we go to core graphics, there's the UI folder and there's like panels and all the panel images, and you can override that. You can create mods that override this and make them look different and make the colors different and all that stuff. Okay, so that's why it looks like this. It's just like a preview. So I'm trying to do one of my mantras when I'm working with Unity. I'm trying to do the least possible amount of work in the Unity editor and the most possible amount of work outside it in plain text. So either JSON files or C#, because that makes it much more easier for me to live with, because like I have no problems usually upgrading Unity versions. Like right now I'm using 2022.3, but I already have a branch of this project migrated to Unity 6 for the next major update, and the migration was fairly simple, very straightforward. While lots of older projects that are very tightly coupled with the Unity editor are stuck in old versions because they just cannot upgrade for some reason, especially if you're using assets. Oh, was that a bug? Affected by ship rotation. Oh, it's because I disabled and enabled the camera. Okay, that's not a big deal. Okay, so now let's see. We covered how the buttons work. So we have the prefab. Now those prefabs are spawned. There's this main menu class, which looks pretty horrible. So just it's not representative of the whole code base. It's also very old and ugly, so it evolved over the years to be what it is. But we're building the main menu using these buttons. So it's just like, yeah, from code, spawning those buttons, instantiating them, and then paginating them. So there's some logic here. For example, if you go to load menu, there's pages. You can use the scroll wheel to toggle, and this whole menu rebuilds dynamically depending on what you press. And yeah, so it's kind of like a dynamic tree. Okay, so nothing else that is interesting here. So it's just menus with configurations and all that. So let's maybe go into the new game and see what happens then. See, we want to start a new game. So we go choose a scenario, click start game. So let's see what happens in the hierarchy. We are now in the game scene. We're no longer in the main menu scene. The root has changed. And also, if we just close everything and open the game scene, where's the game scene? You'll see that it's also pretty empty. It does have a little bit more than the main menu, but it's still pretty empty. So again, what happens here? There's this UI root loader. So there was the UI menu root in the main menu, and here we have another UI. So this is like probably the ugliest and the biggest game object prefab with hierarchy that there is. And it contains mostly like containers for other UI elements. So it's not a whole UI by any means, because the UI is way too complex to be like immediately visible in the whole hierarchy. So it's, for example, we have context menu, right? So if you go and right click some object, a little menu like this pops out, and it has like entries in that menu. So in that UI root prefab, what we're actually keeping is just this container, which is basically a game object with a script with a model behavior attached to it. So let's actually take a look at that. So I'm just using this as an example. Like one of the things here is the context menu. So there, if we open it, prefab open in context, so we're going to see that it's just like this rectangle here. And it has a script UI context menu and a little bit extra like canvas, scalable UI element. That's some custom code for UI scaling when you have different screen resolutions and stuff. So let's take a look at this UI context menu. It is a container that has, well, key item here is the UI data block list view. This list view is used all over the place, and it is used to build all those list UIs that we have, like the info panel, the events panel, the context menu. All these things are built using this. Even the panels that have two blocks, like left and right, also both the left and the right block will be using this list view. And this list view has a pagination. So pagination, I think it's built into the list here. Yeah, UI pagination scroll. So this is responsible for saying which items are visible in the big list. But I have a separate video about UI. It's a little bit outdated, or it's actually very outdated, but it has a lot of explanations about how UI works and how it's built from code. Well, the last thing I will show you how the UI actually is built. So for example, when you want to show that context menu, right, you want to fill these items out, you have to build a list. And it all starts with a little class called UI data block, which is shortened to UDB. UDB equals short for UI data block. I do like short names. So in the project, there's a lot of short names, especially in classes that are very frequently used. So for example, def is short for definition, obj is short for object. There's a class called D for debug. It's used for logging and for dumping some information and all that. So just all the utility methods in D classes for debugging is way more convenient, because this class is used. You'd see that it's well, it's used in how many places there? 5,000 locations. So I saved I don't know how much characters and typing by just naming this D instead of naming it debug. And there's a.cs for shortcuts. Commonly shortcuts. So for example, a.grid will give the electricity grid. A.is in hyperspace will tell you if you're in hyperspace. It's just like shortcuts. S is game state, but it's the variable name here. So whenever you see S in the game, it's a variable. It's a game state. So now talking about this game state, it's probably out of scope of the Unity project. It's the game's architecture. But I think I'm going to touch that a little bit as well, but probably a little later. So, okay, we figured out how we load the UI in the main game right now, yeah? What else do we have? So what are the things that are interesting here? So if we look at the game, what does it contain of? The game has logic, right? So there's like things happening, so or simulation. It's called simulation. It also have visuals. So this is the things you see, people walking around, tiles and stuff. It has input. So this is player input. It also has UI. So I brushed up on UI right now, but nothing else. Also, it has audio. And also it probably has some technical things like glue that builds everything, like puts everything together. Yeah, so UI. We scratched the surface with the UI by showing how prefabs are loaded dynamically through prefab loader, and how we build the UI. There's a separate video about the UI, as I mentioned. I will link this in the description. Now, let's see. Also, maybe let's add one more thing, like plumbing. I'm going to call it plumbing, because plumbing basically is what I call when you have, let's say, main menu, and you press a button and you suddenly want to be in the game and actually spawn the state. You want to spawn the whole environment. You want to spawn everything. You want to set up the game so it would be played. You want to set up all the systems. You want to just do, well, you want to prepare the game engine to run your game, right? Instead of show the menu. So this is what plumbing is about. So for plumbing, there's this main class. I'm going to probably go through it starts in main menu, maybe. Let's open the main menu scene. Resistance. Also, I have to say that I've set this project up 5 years ago almost. So it's huge right now. It's 300,000 plus lines of C# code and lots of things I haven't really touched for years. So forgive me for being forgetful here. I don't remember everything about everything. So I'm trying to find a thing called Bootstrap. There it is. So the Bootstrap, it's in persistent utils. Now, what is this persistent and why is it here? So persistent has this script persistent object, which is very simple. It just says do not destroy on a load, which means that anything that is added to this persistent object will be carried over from one scene to another. So if we draw like the scenes here, there's the main menu scene. I mentioned there's the empty scene. For simplicity, we can skip it right now maybe, but let's wire it up later. So if we create a persistent object there, so there's a persistent game object in this main menu scene, right? And there's also other objects, so runtime objects, like UI of the main menu. So when we are switching from one scene to the other, what happens is that persistent object actually survives the switch and is getting carried over to whatever we end up. Yeah, wherever we end up, it's just carried over. And when you go back from game to main menu, it also gets carried back to the main menu. So that Bootstrap thing is here for a reason. So it's basically our, like in other code bases, you probably find it called something like game manager, but I have allergy for the word manager. So there's 0 classes in this project that have manager in the name. Yeah, there's systems, there's things that do something named according to what they do, but not managers. Okay, so let's take a look at this Bootstrap thing. So it's also going to be pretty nasty, but it's going to be an old code. And yeah, so it's basically setting everything up when the game starts. So this Bootstrap awake is basically the entry point of the game. As you can see here, default execution order is very early, so it's going to be executed earlier than anything else. So we do just some setup here. We set up the stuff, so to speak. But the interesting thing here is the init services. Now, I have a wrapper for coroutines, so I'm actually regretting that I use coroutines, but back when I started, coroutines were probably the only way. I don't think that async await was in Unity at that time. And yeah, so I'm using coroutines in plumbing quite a lot to do like asynchronous stuff or stuff that lasts more than one frame. So this init services is actually what loads the whole game. So, and coroutines class is just quick overview. It's just so I know what coroutines are running. You could just do a regular start coroutine, but this allows me to basically, you know, if you worked with Unity, you had some bugs where, if you used coroutines, of course, you had some bugs where you launch a coroutine and then somehow it just keeps running forever and you don't have any idea what that is and is it running and why is it running. So my tip is that if you're working on a Unity project, and if you're using coroutines, first tip is not to use coroutines, but if you're forced to or have to use coroutines, at least write yourself a coroutine handler or a manager, so to speak, that will know about every coroutine. So instead of just running coroutines directly through Unity, the way Unity is meant to do, I'm having this coroutine start, where I can say what is the coroutine, who started this, so the object, the reference to the object who started the coroutine, and then the name of the coroutine. So I could look at this in the inspector view if I want to, and coroutines exposes the running coroutines with their names and who started and like owners and so on. So then also there's this system. So for example, when you switch from scene to scene, and if there's a coroutine that is not belonging to the system, it's going to be killed. So for example, if you're animating a visual effect in the game and you switch to main menu, the visual effect may be running through a coroutine and it's not a system coroutine. And then if you would not have this system, this coroutines management, it would maybe keep running while the game scene is already over and might spit errors about some game objects being destroyed and stuff, or you would have to handle it inside the coroutine. And here we just have this thing where some coroutines are not system coroutines and then they just get killed when they don't, when they come out of scope of the scene. Okay, so that's probably too detailed, but we have this on scene changed here. So there's a couple of scenes here. If it's a main menu, we're doing some cleanup. If it's empty, we're preparing for a game. And if it's a game, we are doing a bit more. So there's this post init action. We can, okay, probably, again, how to explain this without getting in too deep. Maybe I'll just say this. Like when we're in the main menu and we click a button to start a new game, we set a Blackboard key. This BB stands for Blackboard. So we basically, what is a Blackboard? There's this pattern called Blackboard pattern. So you can imagine a Blackboard like a school Blackboard where someone comes over and writes A equals B. So then someone else comes over and says, hey, what's the value of A? Okay, the A is B. So it's just like a data exchange between things. So you can exchange data between scenes like this. And when we start a new game, we just set this global post init action in the main menu to be new game. And here we check, okay, if it's a new game, we start a new game. If it's a load game, we load game. If it's a start tutorial, we start tutorial, and so on. Just to show how this works, let's open load game panel. So this is a panel which is displayed when you choose to load a save file. And there's this load game with validation. Here's, of course, it's a production project. It's a real world project. So there's a lot of extra boilerplate around everything, like version checks and stuff. So it's not something simple, unfortunately. It all starts out very simple all the time, but it grows over the years. So we have this load game, right? And here's where we set this post init action. We also set the variable names, like what's the save file that we're loading, what's the game name. And then we load the empty, as I said, to clean things up. And then we load the game afterwards. And yes, that's how we switch between scenes. So when you click some button, you say, okay, I'm ready to load the game. We set some variables and load. So then the Bootstrap notices that the scene changes, and then it's say, what do we do when we load game? We enqueue a command. So there's this concept of the command queue. Let me quickly explain what it is. So I have this, it's called CMD queue, but it's short for command queue. Again, I like short names, as I mentioned. So command queue is where you have a bunch of commands that you can enqueue. So like, for example, load game command. I'm just like the code says, some code like bootstrap, in this case it's bootstrap, it's creating this load game command object and is putting this into this queue. And then every frame, we try to execute things in the queue. And the reason why we have a queue is sometimes you want to do things as soon as you can, but not everything at the same time. So imagine that when you're running a game, you have like a budget of 16 milliseconds every frame. You can imagine like if this is 60 FPS, you have 16 milliseconds budget, and there's just so much you can do in 16 milliseconds. But let's say you have a huge explosion on your spaceship, right? It's a space game. So let's say you have like explosion, and it destroys a bunch of tiles, and then you have like 20 explosions from something queued up, and it has, each explosion can spawn new things to the queue. Let's say this explosion spawned like remove tile, and it spawned a ton of these things. It's ton of these things. So you can imagine how big this queue can get. So the reason why we have a queue instead of just executing everything immediately is that sometimes you know that these actions can take a while. So what we're going to do, we're going to try to execute as much as we can per frame, and then we just yield. In this case, we allow render. So we allow the frame, and then we do another batch as much as we can, and then render again. So this is a bit of way to mitigate spikes of lag and allow the game to run smoother. And it's also useful for slow commands, like for example, when I run load game, so I know that this command queue will execute this, it's a coroutine, so it will execute this coroutine for as long as needed, and loading a game is a heavy thing, so it's going to be loading for like 3-4 seconds maybe. And when it's done, it's going to execute the other commands in the queue. Yeah, so that's how we switch from scene to scene and start game and load game. Now, what else do we need to cover here? So this is plumbing, right? So we're talking about plumbing right now. There's way more to plumbing, but I'm probably not going to get into this too much. I guess like saving and loading everything is probably plumbing. And so on, but okay. So let's maybe go into things like the more interesting stuff. Like how do we, let's take a look at visuals. Like how do we visualize everything? Maybe no, we should start with simulation, because you have to show something. You need to know what you're showing. So what happens when you start a new game? I'm going to go quickly again, run. Start a new game, and we'll see what's happening in the hierarchy, and I'm going to explain what do we have running at the moment in terms of the game state. So yeah, we're going to touch the game state next. Now I'm going to just skip these setup screens because they are worth separate explanation. But if we start a new game, and we finally can have control here, and we can interact, we can build things. So by this point here, what do we have? So the simulation, when we start a new game or load the game, it creates a class called, an instance of the class called game runtime. Every single game has separate runtime, and it's very strict, and this is because all the things that are happening inside the game have to be under this runtime, because when the game ends, when you switch back from game to main menu, back to the main menu scene, this whole runtime gets whacked, and everything that is underneath the runtime also gets whacked. So it's basically garbage collection happens. And if something has references that do not like static variables, for example. If there's something that doesn't belong to the runtime, it becomes a memory leak if you go in and out main menu to the game and back and load a different save. And this is actually a killer. The memory leaks are killer when I'm running tests. So for example, I have 300 some, well, over 300 tests. And all those tests are working in a way that they load a file, load a save file, go to main menu, load another save file, go to main menu, and yeah, they're loading lots of files and then doing something with those files and then loading other files. So if I had memory leaks, those would kill the machine very quickly. So that's why it's very important to not have any memory leaks when we switch between main game and the main menu. And also, it's not just that, it's also disrespectful to the player to have memory leaks, I would say. Okay, so game runtime has the game state. So this is probably like the most important thing. And also it has game systems. So game state has a lot of stuff in there, and game systems has systems. So, game systems has things like, see, path system that handles path finding. It has atmosphere system that handles oxygen heat transfer. It has rendering system that renders everything. It has expedition system that handles expeditions. It has, well, there's like 50 plus, maybe more systems right now for all different things and such. And then game state. Okay, so game state has things like entities, which can be, there's 3 types of entities in Stardeus: tiles, objects, and beings. Yeah, so game state has all these things. And with tiles, it's a little bit actually more interesting because tiles are split into layers. So we're actually now getting deep into the simulation here. I can show you the layers very quickly if I go to this frame debugger and then try to render things. So we just rendered the floor. So this is like the floor layer rendered, right? But this is, I'm talking not about graphics when I talk about layers. In every cell of the game, you can have a floor piece. On floor, you can have a wall or an object or nothing. And then you can have various resources lying around, and then you can have beings moving around. So here's where we draw the walls. So this is the wall layer being visualized, and then we visualize the objects. And then we visualize all the materials. Sorry, not objects, we visualize devices, which are tiles. So we're still in the tile world here. So tiles are tile grid-based. So yeah, all tiles sit on a grid. And objects and beings, these things, materials and stuff, are loose. So they can move around. And they don't have fixed coordinate. Well, actually I'm lying. They belong to a grid cell, but also they have a specific coordinate in vector2 form, which is vector2 float. I mean, it could be like 10.5 on X and 10.7 on Y. So it would actually belong to 10.10 on the grid, but it would have like a more precise position. Yeah, so, okay, let's get back. By the way, I just pressed this button here, which opens the frame debugger. So this is how I got to this debugging view. Okay, so I'm actually getting too deep here, and I will take forever if I go into that depth. But I still need to address one more thing. So entities are these things, either tile, object, or being. But then there's also components. It's also a very important concept. There's components, which are in the game state. And now components are the things that make entities up. So let's say there's tile transform component. All components have suffixes comp. So for example, every tile has this tile transform component instance of that. So there's a lot of them, and each instance of the tile. So these are this is the class, and this is also class. No, this is instance of the class. But what I'm trying to say that everything that you select here, for example, like these things, are entities which have multiple components in them. And these components are automatically exposed right here in this list. So for example, the tile transform component is this one. This UI element is created by the tile transform component. There's constructible component, which means that the tile can be built. And that constructible component is right here. So in not constructed, it's looking like that, and constructed tile is looking like this. It has a deconstruct action, and here we can also click get a sub menu, so it shows how, like, what materials does it contain. Right here it contains 2 steel plates. This one hasn't got any steel plates, but if we wait long enough, someone will build it. And now these plates are loaded, and now the object is built. So these are components. These are exposed through components. Those UI elements. So components actually expose their UI. So one of the tasks of components is to expose UI and controls and do something. Then, yeah, so components expose UI. Systems, actually, some systems use certain components. So for example, okay, path system is not using tile transform component, but I'm just going to draw a line here as an example. So some systems can use components. Well, we could have as an example scan system. There's a scan system which uses radars to scan space. So the radar has a radar component. So radar object has a radar component. And the scan system, what does it do? It asks the state. Actually, I could show you. Scan system. And radar component. So there's this radar component. What happens on late ready? Okay, so this is like the life cycle. There's this on late ready, on remove. After tick grid is for electricity. There's receive, where we can send messages across components, and so on. But what I'm trying to say here is that, for example, this radar component, when the object gets loaded or created, it adds this to the scan system, and then the scan system keeps track of all the radars here. And then there's this ticking in the game. There's a clock which ticks. And then it does like go through all the radars and add their strength. If radar is active, it adds their strength. And then it scans. If the player is scanning for something, it actually scans using that strength and updates the scan progress and all that. So just an example how things can work. Okay, so this was the simulation part. It's a very, like, again, scratching the surface, but there's just a rough idea of how the simulation works. So there's this game runtime that handles all this, like holds all this, game state, and systems, and components, and entities. Tiles are in layers, so walls, floors, and devices, or objects. Okay, so visuals. How do we render things? That's also very interesting, because if you would look at hierarchy, like just to be curious, let me select all objects. So I just selected only the objects that are lying on the floor. There's 268 of them. And of course, if we select all the tiles, like floor tiles, I think if I double click, no. Well, if we select walls, there's like 300, 400 wall pieces, even more, I guess. 479 wall pieces right now. Now, if you imagine that this should be game objects, it's not. And I'm also not using the Unity tile, 2D tile system, because it wasn't there when I started the project. Or if it wasn't production ready. I'm not sure if it's production ready right now, but still. And here, if you look at the tile map, it's empty. It has this data overlay, but it's empty. So if you look at the inspector, it has the map renderer class. Now, what does that map renderer do? If we go to the scene and we try to zoom out, we'll find this ship here. So as you can see, there's no game object. You can click around. It's just a mesh. If we switch to 3D, you can see that there's some stuff here. So there's multiple systems for rendering. The map itself, like the tiles and the walls and the devices, are rendered through one method, while all the moving objects, all the particles, all the info icons, all the materials are rendered through a second system. And I'm going to talk about the second system as well. It's going to be a bit weird because, well, spoiler alert, for the rendering of the moving objects, I'm using nothing other than Unity's visual effect graph. Yes, so you heard that right. Visual effect graph is meant for particle systems. So all these things are particles. For Unity, every single, this is a particle, this is a particle, this is a particle, the drone that is going around is a particle, this dead body is a particle, the skull above the dead body is a particle, and this dude here is a particle. Although the only game objects when we have these guys here are the name text, because for each name text, we do have to have, unfortunately, we do have to have the game text instance. So it's one of those rare occasions when we have an actual game object. While there is no object, there is no game object for the colonist or for the bubble here, but there's a game object for the text. It's unavoidable. I didn't find a way to make it without a game object. And now you might ask, like, okay, so how do I debug, right? How do I debug? How do I, for example, I want to know what components this Borg has. So, well, this is my debug. This is my debug. This is my component. So, for example, I can say, okay, I want Borg is a being. So I'm going to open being.json. No, it's not like that. It's human. 01.json, and you can see its parent ID is being, and it has two component overrides for the being name, bed user, disposable. So we're now looking at the structure of definitions. These are definitions, so there's like base being definition, and there's the components. So for example, if I know that I want to debug, let's say, flammable component to know if the being can get on fire or whatnot, and I want to see some data from the flammable component, like take a look at what I'm doing. I'm going to find flammable component. I'm going to find get UI block, and here I can already have something. So now there's this get UI block is the code that exposes the UI element here. And if I'm not on fire, it's not going to be shown, but I could just uncomment this. And since I'm using hot reload, you'll see what's happening. Here, hot reload. Well, it finished with warning, so probably because it has a lamp that's not going to work, but let's try. Yep, it's working. So there's this management flammable on fire false, flam on fire false. And this element wasn't here before. It was added dynamically because I uncommented this code. So if I comment this back, deselect, select again, this UI element is gone. So that's how I debug. I don't have to use the Unity, I don't have to click around in the Unity hierarchy. I just do code stuff, and I prefer it that way. Yeah, so rendering. There's this tile map, which has the map renderer. So what does map renderer do? In the late update, it's, well, basically what we're looking for is this tile render layers. We're taking each layer and rendering it, and it's actually a interface, which is unnecessary in this case because there's only one tile layer that is the implementation, so this interface is not needed at all. And what do we have here? We have chunks where we're using, in the end, we're using this graphics draw mesh, which is a low-level Unity call. So this low-level Unity call tells Unity to draw a mesh somewhere. So to be very precise, I could show you again how these chunks are rendered right here. So if I load, you can see that, whoop, see, that's not fully rendered. That's one chunk. So that's one mesh. Then, whoop, the second mesh appeared, right? So it's like frame by frame, not frame by frame, but step by step. It's rendering multiple meshes like this. So each of these meshes are built dynamically at runtime. So when you place floors, for example, what does the game do? The game creates a grid, a mesh, and then it's I think it's 64 by 64. But for simplicity's sake, let's make it simple and small. So I'm just going to do something like that. So it creates a mesh like this. It's empty. It doesn't have these lines. These are just for you to imagine. And then what does it do? There's a texture atlas, which says, okay, that's a floor tile, that's a wall tile, that's a, I don't know, door, and so on. And then what we do, we say, when we place a tile in the game, so you say, use the build tool to order building a floor right here. So what happens then is that in the mesh renderer, when it renders the layers, it says, okay, in the map coordinate, this and that, where we have to have this thing, get me the chunk, this is the chunk that we're rendering, and take this texture atlas, and it's a floor, so stamp this floor right here, just grab the atlas and cut this little piece of the atlas, cut it, and show it right here. Yeah, so just there's these UV coordinates here and the UV coordinates on the atlas, and the vertices have those UV coordinates. So you just assign the UV coordinates for the vertex, and the Unity then tells the GPU to render that part right here. And then this could be another floor, this could be a wall, this could be a door, and so on. So then we have these multiple chunks, and we just show them one by one, side by side. And that's how we render the map. So there's no game objects involved. There's just code and calling Unity graphics draw mesh function. Yeah, so this is super efficient. That's why we can have something like that. You can just take and create like a billion gazillion floors like this, and in the Unity hierarchy here you'll see nothing new, so no game objects will be created, and it's all in the logic and the rendering, and rendering is very efficient. So if you want to see how many draw calls do we have to render this, so it's just like okay, like 1, 2, 3, 4, 5, 6, 7, 8, 9 draw calls to render this whole bunch of tiles. So it's very, very efficient. And if you want to make a game like this, this is the only way. So, well, maybe not the only way, I'm lying, but this is one of the ways. But if you go the game object route, you're not going to go that far, I promise you. So don't use game objects if you're making a game like this. Try to avoid them. Okay, so rendering. The other part of rendering is a bit even more messed up. And this is the particles that show these piggies and materials on the floor and all these things. So how does this work? There's this rendering system. And I'm going to actually show you the visual effect graph. Sprite. The effects are in sprite. This is this one, yeah. So let's open the visual effect. I'm going to open it. Normally you would use visual effects with things like fire, simulation, or something. And since I'm a bit messed up, I decided to use it for rendering the whole game graphics because it's very efficient. It's using graphics instancing on the GPU and stuff. So we have this graphics buffer. So basically, yeah, how this works in the game, and you can see this effect is pretty simple. It just takes the particle system. It has actually 256 slots. So if you have less than 256 beings, you will have one renderer. If you have more, then it will create another shard. So it's like shards, and you can have as many as you like. It will just keep multiplying so it will be multiple systems. This is for efficiency, because if you would have to limit this to like 10,000 up front, so you have to pre-create all these particles. And so it's better to have them split. And yeah, so we're just taking the data. There's this VFXR data, and all it has is this atlas index. So we can say that the atlas with humans and drones is number 1, then the atlas with dogs and cats is number 2, and so on. And then it has the position of the atlas, of the being or of the object that we're rendering, position in the world. It also has the transform and UV. I don't remember right now. It was 2 years ago when I wrote this, so I'm sorry. I don't remember what the transform stands for, but I think it could be the... Wait, I can actually check. Slot. So we have these slots. Okay, let's quickly take a look at the slot. So render slot. Oh yeah, so this is like more, let's say, higher abstraction level. The render slots is what we get when we want to render a sprite. So there's this animated sprite set, and the rendering system asks, well, not asks, but gives rendering slots. All those slots are mapped to data later. And what is this transform again? So where do I use it? Render slot. Oh! Rotation. Okay. So slot transform is actually rotation plus scale. So X and Y, and then... Yeah. So it's just rotation and scale. Yeah. So the sprites can be rotated and scaled, but if we look at the VFXR, yeah, that's right. So we have the position and rotation plus scale. I'm actually gonna write myself a comment here, maybe. Nah, don't need to. And then the UV. UV is where this sprite exists on the atlas. So as I mentioned about that thing here, so if there's a dog right here in this atlas, we can find the coordinates of the corners and say that, okay, cut this dog out from this and then show it wherever it needs to be shown. And then we can also tint things with color. So we can say, make it red or so on. And this, so 3 years ago I added is shadow, and I could not remove it because if I removed it, it would break my... Actually, I could try it again. Maybe this is already fixed, but it would be breaking my project if I tried to remove this. It would not update, so I had to keep it. So it's actually inefficient to keep it. I'm going to try to remove it soon. Maybe after I record this video. So then, yeah, we create this basically we tell the game code tells the render system that it needs to show some sprite in a certain position, and then that system assigns the render slots, which fills the data of this graphics buffer, and then just renders it as a visual effects graph through Unity's visual effects graph system. And if it sounds intimidating, it was intimidating for me as well. I spent weeks working on that, and I forgot everything right now. So it's, I don't know how I managed to pull this off. It's like a miracle, but it works. And it works very well, actually. Okay, so I think we covered rendering. And it's something that I rarely touch these days. So visuals are basically pretty Spartan, but I'm not touching them often. Audio. I'm not going to talk about audio. It's just boring. Like there's a camera. Okay, I'm going to talk about this just very quickly. So there's the audio listener. Oh, there's one thing worth mentioning with audio, actually. This is pretty interesting. So let me actually show you an example. We're going to load a save file, which is big and heavy, and then we will try to see how audio is handled in that one. So let's say you have a massive ship with a lot of devices there, and each device has to emit a sound, right? So let's say each of these, this could work maybe. Each of these batteries here have to have some hum when you're hovering and listening to them. All right. Is there a hum? Well, there's various ambient sounds, right? You can hear the devices. Well, these particle collectors are all emitting sound. So now imagine if I used if every single particle collector in this, I don't know, the person here made 40 of them. So if I had 40 audio sources for these particle collectors, and maybe also 36 more for these, and then 40 more for batteries, and then 12 more for each nuclear reactor, and then for each engine, and then for everything, right? So everything can emit sound. Now, it would be just a catastrophe if I had to create all those game objects. So instead what we have is this. There's this ambience. So you can see these are our different audio sources. So there's like, I don't know, 35 of them, 36. So what happens is that when we're looking at a bunch of particle collectors, the game actually is smart enough to calculate where those particle collectors are. And if we find the particle collector... Where's this freaking particle collector? There we go. So see, this is the source. This is the audio source of the particle collector. It's here. And if I move the camera around, let me see if the source will move along with it. Yeah, see? The source is actually moving around. So the way it works, and actually you can see it's snapping to the closest particle collector that I'm looking at. See? So it's just jumping around. So the way it works is that if you have multiple devices of the same type, it finds the closest device of that type to the camera, and it plays the sound effect of that device closest to the camera. So that's how it works. And I think it's a pretty good optimization. It works very well. Nobody ever complained about the sounds. And it's fast and it's super snappy. So that's probably the only thing worth mentioning about sounds. And, well, maybe one more thing is worth mentioning. When we zoom in, you hear that there's this filter which makes things cut off, like a low-pass filter which cuts off the high frequencies, so we can hear the ambience of the devices. And when you zoom out, the cutoff frequency gets removed, and you can hear the music with all the richness. Okay, so that was audio. So we covered simulation a little bit, scratched at least, visuals, audio, some UI, some plumbing, inputs. Okay, let's take a look at the inputs. So there's shortcuts. You can press buttons. You can hit Q to find the tools, and then when you move the mouse around, the game knows where the mouse is. When you hover an object with the mouse, it actually finds it, and then you can use shortcuts to move the camera around. There's UI. There's user input in a bunch of places. So this input is handled by the user input class, which is also old and horrible. 5 years ago, oh my god. And it's pretty simple. It's like, well, it's nothing special. The shortcuts are just like saying if was that key pressed, then if it's pressed, do something like that, and so on. Then we have the camera controls, which is also responsible for input and for managing the camera motions. It's split into things like camera focus, camera dolly. So camera focus is responsible for following beings or objects that are moving if you want to focus on them, and jumping around to various locations. And the camera controls is handling things like zoom, motion, dragging mouse with the button pressed, and scrolling the camera around, all that. So yeah, not much to talk about input. The only thing worth mentioning is that I'm using the Unity's new input system, and also the fact that this input is gamepad friendly. I spend a lot of time trying to make it work with the gamepad from day one. So you can play this on Steam Deck and it will work more or less fully playable. Well, it's Steam Deck verified on Steam, so it's fully playable without keyboard and mouse. And is that it? Well, I just scratched the surface, but I hope I shed some light on how the project is structured. So if you want to like write mods for it or just do something with it, use something similar in your own project, go ahead and knock yourself out. All right. Yeah. So that's it for now. If you have any questions or requests, what should I cover? If you're interested in some more videos like this, let me know in the comments. And yeah, see you next time.